You do the millennial pause.
Millennial pause, man.
All right, hello hackers. Camera's not following us. Classic. All right, now it's following us. Okay. Welcome to week. I don't know. Late September, week 2 of the Intercepting Communication module. Where's the slides? We'll do. We're running late, so we'll do the meme review tomorrow or on Wednesday. Sorry about being late. That was uncool. But we'll try to prevent it in the future. Let's start over. The going over the course of the class. First, the thanks leaderboard is completely broken. Hanto would probably just pass this class despite not being an ASU student. The one meme we'll review today is this one that's just brilliant. Hanto is such a good help for the class that he's making the rest of us look very subpar by comparison. Otherwise, we have the usual suspects bringing up the top 5. Good stuff. Keep helping, but also keep upvoting. We've been talking about having to post-process the Discord with like GPT to detect missing upvotes and stuff. Don't make us do that. Thank your friends and people you don't know who help you, not just your friends. All right. How is intercepting communication going? It seems to be going quite well. So a fifth of the people who have, first of all, most of the class has started this already. Do these numbers add up?
It's only if you started. The percents are all if you started.
Including 0?
The 0 is not started.
Not started. Okay. But these all add up to 1,000?
Yeah.
Okay.
I think.
Anyways, out of the 900, oh yeah, I guess it must. Out of the 904 that started, almost everyone has hit the checkpoint. Now, this module is a little bit tricky. The checkpoint is relatively easy to hit. And you just have to choose a number for the checkpoint, right? You chose 30%. 30% in this case is not as hard as as getting 70%. So don't kind of sit on your laurels sort of thing. Make sure to keep going and don't fall behind for the final push. That being said, already fifth of the people that have started have gotten enough to pass this, so as in like 70% or more, which is great. So just keep pushing. As before, the median first solved was the day before. Yeah, it was Friday afternoon, right? The 19th was Friday. Yeah. No, it wasn't. The 19th was Thursday.
Was it?
Yes, because it's the 23rd. Yeah, awesome.
The way the checkpoint was the 22nd.
Yeah, the checkpoint. So we actually got people starting. The median person started earlier than Friday, which was really awesome. Yeah, that's really cool. Okay, awesome. So keep pushing on intercepting communications. On that note, we're gonna dive in and do some hands-on work today. Do you want to start off?
Sure.
All right, let's do it.
Actually, before we start, though, is this still following you? It is.
Yep.
It's called the classic. Almost. Now it's gotta. Almost. This is ridiculous. Okay, there we go. All right. Before we start, though, does anyone have any questions about the structure of the class or questions about the concepts in this module?
Sorry, one thing that I wanted to mention is the 100 people that didn't start. There's like an intersection of, I think, about 84 people that didn't start web security and didn't start this. At some point, if you haven't like linked your pwn.college and so on, that includes non-linkers, right?
No, this is they're linked. Everyone on this
Everyone's linked. Okay.
There's still 20 people unlinked.
So the 20 people that are unlinked, we will start dropping you from the course probably next week. We'll send a couple of increasingly frantic emails at you. but please, double check that your pwn.college is linked and everything is good.
Cool. Yeah, and you know you're linked if you see the setup page, 5 green check marks or however many green check marks, have all the green check marks. Okay, cool. Does anyone have any questions about concepts in this class, things that just aren't making any sense about networking? Before we networking. Oh. I'm not seeing any hands. All right, cool. Well, then in that case, let's go ahead and start talking about some networking concepts. Okay. Actually, instead of going through the dojo, just to make it a little bit easier for ourselves in this case with having the ability to do all sorts of networking, I am going to SSH into a server. But I need another window. And we need a terminal. Oops. Make the nice terminal big text. Okay. And this SSH. Cool. Okay, so I have just SSH'd into some random Ubuntu 2404 server. And I think one of the good ways to really think about networking or to kind of demo some networking concepts is using Docker. Who here is familiar with Docker? Is anyone here? Okay, cool. So some number of people. Okay, you don't have to worry if you don't know about Docker. We'll kind of maybe do a very quick rundown. And actually, I'm going to kill all of these containers because we'll just start from scratch here. Cool. Okay.
That was the dojo.
No, it wasn't. Nice try. Okay. So Docker allows us to spin up little environments of sorts. You can kind of almost think of it as a virtual machine. People that like Docker will yell at you and say it's not a virtual machine. They're right. It's more efficient. It has to do with this thing called namespaces. And in these challenges, when you do challenge run and it says your root at IP dash blah, 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 the thing that we're dropping you into is a new namespace. And it's a new isolated network namespace that then lets us start doing cool networking stuff. And Docker operates under the exact same model. So for example, I can do Docker run, and Docker run is just going to allow me to start up a container. And I'm saying -it -rm. These things, they don't really matter. If you're curious, it's making it so it's interactive, there's a terminal, and it gets deleted after it's killed. We'll create a name, and in this case, we'll give it a name of server. So I'm going to maybe demo setting up a little HTTP web server for networking purposes to analyze that. And then we will just say, we want the latest version of Python as our thing, and the command we want to run in that thing is bash. I know this is a big, long string of text, but actually, it might be worth, as you kind of progress in your CS careers, starting to get a little more familiar with Docker. Docker is just like one of those tools that turns out to be very useful for a whole lot of things. If you've gotten familiar with Git, I would say Docker is like, not necessarily in the same tier, but it's a big standard tool that a lot of things use. Okay, so now we've got a nice little changed host. So it's just like the challenge, right? Before we had stream at Ubuntu server. Now we are root at, well, this doesn't look very exciting, but this hash thing. Okay, and actually before we do that, we're gonna kill that, let that die away, just like when we exit the challenge and it dies away. I am going to start up a program called tmux. On the topic, who here has used tmux before? Okay, a few. So on the same topic of Git being super useful and Docker being super useful, turns out tmux is another one that's super useful. Or if you're old-fashioned like Jan and you like GNU Screen more, that's also cool. Yeah. But
it's all depends. Do you need something reliable or something flashy?
Yeah, exactly.
One or the other.
We're going with the flashy thing in this case. And it's the flashy element here is if you look at the very bottom, right? I type tmux, hit enter, and then we're just like back at it. It seems like almost nothing happened. I guess unless you're paying close attention, this little green bar at the bottom showed up. This green little bar is the tmux bar. And you'll see that there is a 0:bash. Basically, TMUX stands for terminal multiplexer. So if you've ever, gone into the desktop and you've started up like a terminal window and then another terminal window and another, we got like 3 terminal windows. That works fine. But a terminal multiplexer kind of allows you to have multiple terminals within the same terminal, right? It's multiplexing. It's a terminal multiplexer. And what that means is that if I type something like ls, which isn't very exciting because I am in a fresh account that has no files, or I type who am I can start up a new terminal. And it's a new terminal through SSH. So SSH is, we're still SSH into this box. And if I hit Control B, C, suddenly there's a new terminal. You'll see that the bottom bar changed. Now there's 0 bash and 1 bash. And if I hit Control B 0, we go to 0 bash. If I hit Control B 1, we go to 1 bash. We got 2 terminals. It's a terminal multiplexer. And then there's, stuff at the bottom right that kind of says where you're SSH'd into, what the time is. Doesn't really matter for our purposes. But this is a terminal multiplexer, multiple terminals. So you're going to see me as we kind of demonstrate this, possibly rapidly switching between terminals. You'll know that the little star at the bottom is moving around. And technically, you can name these things. I mean, I use TMUX, but only the basics of TMUX. I have no idea how we rename one of these things. You can make it so it doesn't say 0 bash. You know how to do it?
Yeah.
Oh boy. See, title it.
That's the screenway. I don't know. Name? Okay.
If you're excited about it, there's going to be like a TMUX cheat sheet online that'll show you like the 20 popular commands.
No, I'm curious.
Honestly, I haven't spent enough time doing that. All I need to know how to do is create a new terminal, Control B, and then C for create, and then Control B0, Control B1, Control B2, or Control B arrow keys to like move left and right. That's really all you need to know. Technically, you can also start like splitting the window in half vertically or horizontally. You can do all these fancy things. What is the rename one?
Control B, comma.
Comma. Okay, Control B, comma, I guess lets you rename. So we'll rename this one then to server because we're going to start up our little server host thing, our namespace, our Docker container on this 0th one. Control B, comma. I'll try and remember that. Okay, and then you can see there's a star next to server. That means we're on the server window. Okay, let's see if my Docker, I don't think I still have my Docker run. We'll type Docker run again. We will run itrm, and then we will do name equals server. We're going to say we want the Python latest image. Basically, this is going to be like a little file system ready to go with Python in it. And we're going to start up the bash process. Okay, we are now in our container. And when you spin up a new environment, just like when you start a new virtual machine, normally there's not a whole lot of tools in there. In this case, we have Python because guess what? We did the Python image, but we don't have, for example, the command maybe you've grown used to in this module so far, like the IP command, which means we have to, install some stuff. So we'll just quickly install some useful tools for doing networking. Let's see what I can think of off the top of my head. IP route 2, netutils. Does that have? Here, we'll start with IP route 2. Oops, apt install. IP route 2, netutils, net tools.
Yeah.
Net tools. Is it dash?
Yeah.
Net dash. Cool, and we'll install more things as we need it, but right now I just want to be able to type IP space A. Okay, looks just like the challenge environment, right? We've got a loopback interface. I think this one's a little bit more boring. It's not all colorful. I actually have no idea why the one on the dojo is like colorful. It's kind of nice, but it's the same output here. We have our loopback interface. We have our ETH0 interface that you've maybe gotten accustomed to. And we can see we have an IP address. Our IP address is 172.17.02, just like in the challenges when you're 10.0.0.2. This is our IP address. And so if I want to, spin up a very basic web server, so for example, oh boy, what did I just type? Oh, that's a caps lock, I see. If I want to spin up a very basic web server, maybe you have used this in the past, maybe you haven't, Python-m HTTP server spins up a very basic HTTP server. And it says serving HTTP on 0.0.0, which means, as we've learned, any interface, port 8000, which means I can talk to this thing right here. So now, because I've got my processes stuck, right? It's serving. It didn't give me my terminal back. This is like where I use tmux, right? Like this window, it's not dead. It's like doing stuff. I'm just going to leave this window behind. I'm going to hit Control B1. And let's make sure that we can access this IP address. So if I run IPA on the host, you'll see I have a whole bunch of interfaces. Again, this is SSH into a server. It's actually SSH into a server that's sitting right next to the pwn.college dojo. It's like, I actually haven't been in the room. I don't know if the box is literally above or below, but it's touching the same box. You'll see we have a whole bunch of interfaces. We still have that loopback interface we've gotten used to. And then we've got this Eno1, Eno2. We've got this Docker 0. I mentioned Docker. Docker spins up a network interface so that it can do its networking. You'll see here that it's 172.17.0.1. And if you remember, I don't blame you if you didn't, this guy was 172.17.0.2, right? These IPs are right next to each other. So these guys can talk to each other over this Docker 0 interface. So from the host, it's the Docker 0 interface. From this container, it's the ETH0 interface, right? They're technically all in the same box, but maybe it helps you think of them as different boxes. We just have these little namespaces, these little networking namespaces that are networked together in various ways. So ETH0 on this namespace talks to Docker 0 on this namespace. They're part of the same network. And so what I can do is I can curl, let's see here, we'll copy this IP address, curl this 8000, and this is the response. So if you've ever used the Python HTTP server, I think we've talked about it in the past classes. It just basically it's doing an ls, but returning it with HTML. And so I could also do slash, bin or something. Maybe. I thought I could do slash bin. Why can't I do slash bin? Oh, am I? No, I'm not in my home directory. Is there nothing? That's not possible. Oh, it's doing a redirect by, well, actually, let's see it. If I do curl-v to wonder like what the heck is going on here, we will see 301 moved permanently, and it's redirecting me to /bin/. So that's why I'm seeing nothing. If I put a slash at the end, now I can see all the files in bin. It doesn't really matter. This is just a service on the network that we can communicate with. And if I wanted to see the network traffic happening here, I could, let's see here. I could list my Docker containers. We'll see I have this server container. If I want to get another terminal inside right next to this first one, right in that same network namespace, the Docker way of doing that. So unfortunately, in these challenges, you don't have a way to like enter into the challenge namespace other than just starting up new processes in it. Docker is much more convenient. You can actually re-enter into that namespace. We can docker exec-it server, and we'll start up the bash process. And now these two terminals are in the same network namespace. And the reason I want to do that in this case is let's just use TCP dump. Let's see the traffic happening. So if I do TCP dump-i any, and it says, as I said, there's no tools installed in these Docker containers. We will install TCP dump. And then we do TCP dump-i any, and we start up yet another another terminal, right? This is where tmux is kind of nice. We just have lots of terminals because this guy's busy, so let's get a new terminal. Let's go ahead and curl, oops, that's not what we want. Let's curl this IP address on 8000. And now we can see a whole bunch of packets came through, right? So we've got this, the thing that like is drawing my attention right here is the IP address. So this came in from .1, and TCP dump by default is very nice and tries to do like reverse DNS stuff. We can actually disable that real quick with -n. We will curl again. We will scroll up here, and we will see that .1 sends a packet to .2 on port 8000, and .1's on some random port, and we're looking at a TCP packet. It said it sent a SYN packet, SYN packet. And if you've watched the videos or you've kind of progressed through the challenges, you'll know that if we want to start a TCP network connection, we have to do this three-way handshake. We have to do a SYN packet. The server is going to respond with a SYN ACK packet. Well, right here, this is that SYN ACK packet with .2 talking back to .1. And this is just the TCP dump format. It uses a dot to represent an ACK because turns out in a TCP interaction, you're almost always acknowledging stuff. There's like rare cases where you're not setting that ACK flag. Like the very first packet is an example of one spot where you're not actually acknowledging, but in most spots you are also doing the ACK, so I guess they made it a dot to not be too visually distracting. And then we complete that three-way handshake with a acknowledgement packet. So we could look at all of this information. We could, as we've shown in previous lectures, we could look at this in Wireshark. It's actually going to be a little bit tricky if we wanted to look at this in Wireshark, just because we're SSH into a box, and that SSH, like we don't have a graphical environment right here, which is why the desktop is useful in pwn.college. There's ways to get around that. The -w flag would allow us to do like info.pcap. And suddenly now we're writing out to this pcap file, and then Wireshark can open that pcap file if we wanted to. But we're not super interested in that right now. TCP dump is showing us all sorts of things. It's showing us, for example, the sequence number, the acknowledgement number, right? We learned in the three-way handshake that the SYN ACK packet that comes back as that second packet in the three-way handshake should be one more than the sequence number. So this ending in 7, now it ends in 8, right? They acknowledge by incrementing 1. And every time you send data, you acknowledge, add that many bytes to acknowledge it. Highly encourage you to watch the lecture videos if you haven't already, to just hear about the theory of that three-way handshake. And then we see all sorts of more data going on here. And that is that. I think in the past we showed off this IP routes command, or actually, I think Jan uses a different command. What did you type something other than IP route? What's your?
Oh, just route.
Oh, just route.
I'm old hat.
Oh, it does exist.
Yeah, it's very nice.
Yeah, I guess. I
mean, they're the same.
They're the same thing. I guess route is actually, it kind of looks a little nicer. Yeah.
Also,
But
if you've been using it for as long.
Yeah, exactly. Or maybe you're more used to like IF config. I feel like IF config used to be the standard way of doing IP space A. I don't know. At some point, Linux decided, or GNU, or I don't know who the heck decided, that the IP command will just do it all. And like you type arp-n.
Mm-hmm.
I think you can do IP-nay. I think is the same thing.
The fuck?
Yeah, IP-nay. I don't know.
Neighbors.
That would make sense. Yeah.
You can see it.
Either way, there's a lot of commands to do things, and they all do different things depending on, kind of what your objective is. So this tells us right here, when I type this IP-nay command, what this is telling us is that one of its neighbors is 172.17.0.1, and it is on this MAC address right here. As it says reachable, which is kind of cool. It says this is going to be over the ETH0 interface. So this means that this host currently knows how to talk to 172.17.0.1. When it's setting up that destination MAC address, it is putting this in there. And the reason that it knows that is because at some point it did an ARP who has, and then someone replied ARP is at. And it was very nice, and that was the whole ARP protocol. In fact,
can you show that?
Let's see if we can see that. The issue is it's still it's stale now. Yeah. Okay, let's run TCP dump ini. Actually, and then we'll also do -n to make it so it doesn't resolve things. Let's go ahead and do a curl back there. Let's see if our...
You can do IP-nay flush, by the way.
Yes, and you'll see right here that we get these ARP requests who has. So we can see right here, there's a lot of text going on here, and you need to know how to decipher it. But maybe it's kind of, I don't know, readable. Hopefully they made it readable for humans because that was the whole goal, is that on the ETH0 interface, going out of that interface, so this host going out to the ETH0 interface, we had an ARP packet. And that ARP packet was a request. And the request was for type who has. And if you think back to the lecture videos, these are all just bytes somewhere in that packet. I think who has is the operation 1, and I think we'll also see there's an is at, which I think is op2. These are just hard-coded numbers. And it says who has 172.17.01. Tell 172.17.02. And so this was that ARP request happening. And it looks like we also received, we actually didn't immediately receive a reply to that who has request. We actually immediately received another request coming in through our ETH0 interface saying, well, who the heck has 172.17.02? Tell 172.17.01. And fortunately, it knows how to reply. I believe it's kind of up to the kernel to determine how it wants to implement this. But this packet right here that has that who has the source MAC address. So it knows how to reply. Alternatively, if it didn't know how to reply, because this almost seems like a chicken and egg problem, worst case scenario, just broadcast the answer, right? You can always broadcast. This is how this whole process initiates, is I don't know where 17.02 is, so I'm just going to set my destination Ethernet address to be FFFFFFFFF, and that's a special MAC address that just means go to everyone. I just want to broadcast this packet to everyone, and so everyone receives the packet. And then we can get more specific once this ARP has, well, what the heck is that, has been completed. And so we see then also we get our replies. We reply saying, hey, 17.02 is at this guy. And we also receive that reply coming in saying 17.01 is at this guy. Okay, so this is the core networking stuff happening, right? We have TCP over IP over Ethernet. And then somewhere in there, we've also got this like little utility protocol called ARP that's doing that translation between IP and Ethernet to kind of bridge that gap of nearest neighbors. And the reason that they're near neighbors actually has to do with, I think we talked about this on the first day, has to do with the fact that they're part of the same network. So we have this 172.17.02/16. So this /16 has to do with the subnet, which we briefly talked about on the first day. And long story short of /16, this means that 16 bits are representing the prefix. There's 16 bits of prefix for our network, and then the rest of them are inside of the network. So each one of these decimal values here is an 8-bit value, right? It can go anywhere from 0 to 255. So this is 8 bits, and I keep long tapping on it. This is 8 bits. This is another 8 bits. That's our 16 bits. So what that means is this 0 and this 2, if anyone is on 172.17.something.something, they are in our network. And that means when we want to go talk to them, we're going to send out an ARP request to go talk to them because they're in our network. Alternatively, if they are not in our network, that's where we go talk to the gateway. And we can know about the gateway with this IP route command. And the gateway in this case is just default. Or you can use Jan's older command that actually looks nicer, where it literally says the gateway here, 172.17.01. So what that means is that if I ever want to talk to someone in my network, we are going to ARP because I need to know, or unless I already know where their Ethernet is, I need to ARP to figure out where it is. If they're not in my network, it's going to the gateway, and this is where the IP part of this onion of networking really comes into play because that is where, I think Jan showed in his in the last class, the traceroute command, and we could see, let's actually just do it. Do we have traceroute? We don't have traceroute.
You have NTR? Just apt install NTR.
Apt install NTR. 53 megs. Jeez. We're getting icon packs. What is this? Oh, yeah, it does ship to GUI. That's what it was. MTR will go to example.com because we like to pick on example.com. right? And so example.com, actually, before we even look at this, I like to resolve IP addresses with just ping. I don't know. I think everyone has their preferred way. Ping is a nice, easy way to just like, I don't know if you have ping. Ping util.
IP util 6 or something? No.
Chatgpt.com. Stay logged out.
Talk about LLM brain.
Yeah, so
it's inet utils -ping.
See, what I really like this part of ChatGPT, when you don't know how to apt install something, you just say apt install what you think it should be. So apt install ping, and it just comes back to you with the correct command. See, it's pretty good. I think apt should just go to an LLM and just correctly install. Cool. Okay.
That'd be a good CTF challenge.
Yeah. Okay, so if we ping example.com, right, this is on this IP address, 93184.215.14. Random numbers, right? But it's important numbers. And if I look at IP routes, we already talked about this 172.17 business. So if it was on this subnet, we would send out an ARP request. We would like ARP request out to example.com, and we'd start talking to them because they're on our local network. Example.com is not on our local network. It needs to go to the gateway. And as I said before, this is where the real power of IP comes in. You might be thinking to yourselves right now, why do we have IP and Ethernet? They're like both for selecting a destination. This is silly. And Ethernet is for in-network. IP, the services have to do with being out of network. I need to hop around the internet, right? So let's actually go ahead and run that mtr command again, which Jan showed. These are all the hops, or at least the hops that are willing to show us they exist, that are well-behaved and nice. We can see that once the first hop goes to, so as a reminder, we're on 172.17.02. Host 1, the very first spot that our packet goes to is 172.117.01. And then it goes here. I'm not going to list all these IPs over and over. And it hops through. At some point, we end up on an ASU box, or at least something that reverse DNS points at a ASU box. What the heck is VPRS English? Well, you're probably used to ASU, right? If you're an ASU student. And then we end up in some Phoenix boxes. And then I guess we end up in LAX. So I'm just assuming LAX. I'm assuming this server right here is in LA, just guessing off of the name. And then another box and another box. Before you know it, we are at example.com. Okay, so this module requires that you understand this basic level of networking. Unfortunately, we don't have the ability to make a networking class be like a prereq for this class or something. So we try to convey those very, very basics. If you're interested in this stuff, ASU does have a networking class. It's for something. It's, I think, an elective you can take. Would encourage it. Maybe it'd be good to really understand networking. But we kind of just get into the basics, but the very specific basics, because what we're trying to do in this module is understand this idea of intercepting communication, where networking reality and networking facts start to have security implications. And one of those security implications that we really explore in this module is this whole ARP business. So again, right, we have Ethernet IP TCP is kind of like this onion, and then we got this side guy called ARP. ARP brings in lots of security concerns. Because if we look at our, let's do IPNA again, that's stale. So that means if I do TCP dump again, and we show our ARP packets come in one more time, maybe. Where the heck are my ARP packets? Oh, there they are. Okay, here's my ARP packets. We get into the very specific details of how this networking works, because once you understand the precise details of how networking works, precisely the fact that there is this ARP protocol that is facilitating this like kind of glue between Ethernet and IP, this security issue arises. And the security issue is there's kind of like this implied trust in the protocol. So some protocols like take in to build up a security model where it's like, I don't trust anyone, and I am going to know that I don't trust anyone, and this is going to be taken into account in this protocol, which actually will be explored, I think, in the next module, assuming we do crypto next, which I think probably we're doing crypto next. That whole idea of trust will be explored in the next module. This is like actually like a thing you can well define what trust is in the context of cryptography, at least. In the case, though, here of ARP, it's not necessarily that there's I wouldn't necessarily call it a vulnerability in ARP. ARP is just designed how ARP is designed. It's through these facts, though, of how ARP is designed that lends it to being abused. And the issue is that when you want to know where someone's IP address is, you just broadcast to all of your neighbors and you say, who the heck has this IP address? And under a well-behaved system, the correct person is going to respond. The person that truly is, whatever truly is, as we're going to get to, means that truly is 172.17.02 is going to say, hey, I'm 172.17.02, and I'm at this Ethernet address. So when you want to talk to me over this Ethernet address. But I'm saying well-behaved. Like, if you're a host on one of these networks, you can just look at all of these requests and just say, it's me, it's me, it's me. I am this IP address, it's me. And what that's going to set us up for is that all of these people asking, where can I find this IP address, are suddenly going to be sending their packets to you. Because if they want to talk to that IP address and you said, it's me, it's me, it's me, they're going to talk to that IP address. Which means that if you're wanting to intercept communication, you're getting all of the packets. Now, we can do this. Let's actually see how we want it to demonstrate this to really show like, hey, you can just say, it's me, it's me, it's me. What I'm going to do is I'm actually going to start up another Docker container. And this other Docker container is going to be named attacker. And I'm going to add in it one extra flag that wasn't there before. That flag is privileged. And then I am going to say that I want Python latest again because, I don't know, sounds nice. And we're going to start it up. Okay, this is me plugging into this local network, okay? The attacker just rolled up. And the reason I did privileged has to do with Docker basically saying that these containers can only do so many operations. There's a lot of privileged operations that can't be done by default. But if you just roll up to a network, like it's your box, it's your Ethernet port, it's your radio antenna that's doing the Wi-Fi, it's like it's your box. Like privileged operations, we're assuming a model of an attacker just rolling up into your network and plugging in. What we can do now, what we want to do, right? We said the theory, right? The theory is I should be able to just respond when someone says, who has this IP address? And I said that the issue here is like, well, what if some attacker just rolls up and says, it's me, it's me, it's me? Now, this is like easy in theory. Now, how do we put this to practice? In this module, one of the tools that gets explored is a tool called Scapy. And you don't have to use Scapy to do this, but I think it's probably going to be the easiest. Oh, I need to apt update. Pretty sure I can apt install Scapy. And I will do that, which it's already installed in pwn.college. There's nothing special about Scapy. There's nothing special about Scapy other than the fact that it's a convenient tool that's going to allow me to do this task of replying to ARP replies. By default in the kernel, when we do these like network operations, and we'll explore it further throughout this class, there's not like a good user land tool, like a tool like ping or like, well, there actually are tools, but we're going to ignore that for now. Once you want to start sending out custom packets, Scapy is a tool built to send out arbitrary packets. I can just send an Ethernet packet with a source MAC address of this and a destination MAC address of this and a type of it. I can set any of those byte fields however I want. And Scapy is very convenient for doing that. Okay, let's see here. Okay, so let's remind ourselves here from the host. If I do, nope, IP, nay. This is our host saying it knows about a whole bunch of IP addresses. You'll see a bunch of these 206 IP addresses. These are IP addresses we don't really care about. The IP addresses we really care about are these 172 ones. In fact, I'm just going to grep for 172 because these are the only ones we care about. And these are currently stale, which means the next time it wants to talk to this IP address, it's actually not convinced that it's here anymore. Like it knew in the past that it was here, but this ARP protocol, it like times out. I don't actually know what the default time is in Linux. It could be on the order of like 60 seconds. It says the cache is good. Do you know the time value? Is it 60 seconds?
I don't know, actually.
Like
That's
the
a good
intuitive
question.
feel to me is 60 seconds. It's probably configurable. Yeah, let's just call it 60 seconds. Doesn't matter. You are going to do a new ARP request every 60 seconds then, because you could imagine that one person plugs in, has this IP address on this Mac, leaves, someone else plugs in. Now they get that IP address because we're just assuming that that port is statically assigned or something. And suddenly they're a new MAC address. So we don't know necessarily that it's accurate forever. We just say, yeah, it's probably good for 60 seconds and call it good enough.
It's in this
Oh, that is a
conf.
long thing. Proc sys
You
net.
misspelled prog.
Oh boy, that's why I can't tab. Proc sys net. See,
IP4.
all of these things are discoverable. Nay. Do we think ETH0?
Yeah.
GC. Oh, ENO1. Or I guess technically we're speaking over the Docker interface. GC stale time. This guy. 60 seconds. All right, we got it right. That was just the intuitive. It feels like it's about 60 seconds. We'll find out it actually doesn't matter for our purposes. Turns out, spoiler alert, you don't actually care when this request comes in, when someone says, hey, who has this? Turns out that Linux by default is configured to just listen to any is at response whenever, even if they didn't make the request. They might have said, I'm not even asking who has this, but someone rolls up and says, hey, this is here. They're just like, okay, add it to my cache. Which is kind of convenient, so you don't have to wait for a request in this attacker scenario. Okay, so now we've got Scapy installed. We know that time. Got this. We know these are currently stale. And just to show that if I do curl to this port 8000, we get our response. I run ipnay. It is no longer stale. I guess it's delay. I don't know. I guess delay means maybe it's good to go until 60 seconds. Oh, no. Maybe delay meant it was still waiting. Now it's reachable. It's going to go stale in 60 seconds again, though. Doesn't really matter. But that is the evolution here of this ARP cache. Okay. Now, one of the things, I should have had TCP dump running. Let's see if I can get TCP dump running. Apt install TCP dump. Just to see that, like, hey, is this request actually hitting me? If I do TCP dump -I any on this attacker machine, right, on this attacker Docker container attacker namespace, and I run, and I want -n. Let's see if the cache is clear. It's still reachable. Actually, at some point, .3 came out and said hello. But 2 is stale. Okay, so let's curl for 2, and we're going to see. Eventually, I think it should show up. Hopefully, I'm not making things up. Live demos. Where the heck is my packet? How do you clear the cache, Jan?
IP, nay, flush,
Flush.
dev,
Dev.
and then the dev.
Cool. Okay, now let's see if we get our packet. We will curl, which is going to force us to. Boom, here it is. Look at this. Who has 172.17.02, tell 172.17.01? And we're right now on .3. There's no other packet. We just got the request. We don't see, we saw this came in inbound. I think I don't know. It came into us. Someone asked us. And our default running software, our kernel that's running our networking stack, dealing with all of this in the background for us, did not reply because it's well behaved. It knows. In fact, it knows because if you look at this, I guess we don't have IPA anymore. Let's do IPA. It knows because the kernel is just doing what we told it to do. And what we told it to do is know that it's .3. We didn't tell it to know that it's .2. Actually, if I can change this behavior, let's clear it again. I can convince my kernel, because the kernel is just working on my behalf. The kernel is mine, right? If we assume that this is my box, my kernel is running for me. I can tell my kernel, hey, guess what? I am also .2. If I say IP route add or IP route adder add, this is a long command. I think this is right. 172.17.0.2/16 dev eth0. I think this is the way we type this. Hopefully I'm right. Otherwise, I'm going to ask ChatGPT why I'm wrong. Oh, is it just add? Let's see. I'm going to try without adder. We're going to try without /16. Now we're going to see if it worked.
Why /16?
Because I thought you had to specify your subnet also. IP route add. Oh no, I'm adding routes.
Yeah.
You know what I just influenced? I just influenced my routing table, which means how do we delete that now? Oh boy.
I just replaced add with del.
IP route. We're going to get rid of that routing rule. Wrong command. This is, again, where ChatGPT is very nice when you don't type these commands millions of times a day, because I don't type these commands millions of times a day. We just know the concept that we want to achieve. I want to add an IP address. Now, what is my syntax for actually doing that? We're going to find out. IP adder add this. I think this is going to be right. And if it's not, okay, that looks good. Okay, look at this. eth0 has changed. And it's totally legitimate to do this because it's our kernel. All we've done in doing this, obviously we've changed what shows up when I type IP space A. All I've really done, like the core fundamental thing that just happened, is I told the Linux kernel that if you ever get an ARP request for who has 172.17.02, to just say, yeah, it's here. That's really all we've done, is instructed the kernel that that's what needs to happen now. So now if I do TCP dump I-any, and we run that flush our IP cache, curl again, well now, look what happened. ARP who has 172.02, tell 172.01, and we replied. Or, whether you say malicious or whatever you want to call this, our host is now replying saying, it's here. We've got
hijacker.
The hijacker has done it, right? I mean, you might legitimately be configuring a network, though, where this interface should have 2 IP addresses. Really, like, whether or not you're malicious is in the eye of the beholder, I guess, here. But what happens is we've changed the network traffic, right? We've changed it so now we are replying saying, it's here. And then we get the SYN packet. Yeah, go for it, Jan.
I want to just pop in for a sec. Like, this seems like a crazy thing you do in lab settings, but I've heard of people using this exact thing to hijack IP addresses on planes, for example, to get free Wi-Fi. Someone else signs into the Wi-Fi, you grab a clone of their IP and just start chatting. There's some other things that hypothetically someone might have to do to make that work, but it's something that has applications in the real world.
Yeah, this is just what the technology allows for. And in case anyone's wondering, to be extra clear, back to ethics, don't do this, right?
Exactly.
Like, this is explicitly illegal on an airplane, especially. It's illegal everywhere that you don't control the network. It's extra illegal on an airplane. You will end up on a no-fly list. Don't do it. Okay. But we're just trying to understand, what is the technology? How does it all work? This is how it works. And so this is something that you might have to build if you're building up a network someday and you need to defend that network. You need to understand how this works to build up your threat model of how things work. Okay, so then we got another packet. Why do we get another packet? Because now someone's ready to do a TCP three-way handshake with us, right? We ran that curl command. It's ready to start talking to .2, and it thinks we're .2 now, so we're receiving these packets. And it starts the three-way handshake with a SYN packet. And immediately, we respond to the SYN packet with a reset acknowledge packet, which is not a SYN ACK packet. It is a reset ACK packet. And what this is saying, basically translated through abstraction, is I'm not listening on that port. Like, what are you talking about? Why are you trying to talk to me right now? I'm not listening. Reset, go away. And so that is what we respond with. And so that's why over on this side, we get a failed to connect immediately because this guy over here received a reset ACK packet saying there's nothing listening on port 8000. But we could be listening on port 8000. Let's go ahead and flush the ARP cache again. We will open up yet another terminal. There's a reason I started this with TCP dump with tmux because I want a lot of terminals. I am going to get another terminal inside of this attacker container. Oops, exec it attacker bash. And what I'm going to do I have netcat? Nope. apt install netcat. Apt install. It's OpenBSD, right?
And cat, right?
And
no,
cat.
yeah, there you go. Netcat.
Oh, no. All right. And what we're going to do is we're just going to listen on port 8000. Everything happened correctly. We didn't make a mistake here. Everything that should have happened happened. Like, the computer's not lying to us. There's nothing to connect to. If you want to change the behavior of what's going on, make there be something to connect to. So we will listen on all of our interfaces to keep it nice and simple. And we know that this guy wants to talk to .2. As a reminder, just to take a step back, the attacker should be .3, but we've also made it now be also .2. We're just going to flush this cache. This is listening. We've got TCP dump over here running on the side in case we want to see what happened with the network traffic. And now we are going to curl. And it's hanging. Why is it hanging? It's hanging because netcat hasn't responded. We got an HTTP request. We could say HTTP 1.0 or HTTP 1.0 200 OK. What do I want to say? Real fun. Script alert 1 or something. I don't know. Just do whatever you want, right? Think back to XSS, which is a whole new context now that we are literally in control of the server from a networking perspective. Obviously, curl is not going to look at JavaScript with any interest, but look, this is now what happened. This guy wanted to talk to .02. .02 is supposed to be this guy over here. A host plugged into the network said, I'm also .02. And the reason we did that is because it was the simplest way to make it so our kernel that's acting on our best interest, the kernel is just doing what we want it to do, is now ARP replying because we added the address, and so now it'll reply. That's not the only way to do this. All that needs to happen is that ARP is at packet needs to go out. This is one way of achieving that. You could also use Scapy to achieve that. Scapy is this Python wrapper thing with a bunch of libraries already imported thing that allows you to start crafting arbitrary packets. So for example, I can type ether, and this is an empty Ethernet packet. And I could say source, hopefully I get this right, 1.1, or let's do something that looks like an actual thing, 1122334455. And now we've got this. This is just Python objects, right? This is nothing special, but we're starting to encapsulate things. I can put IP on top of that. This is now just a set of bytes, right? It is a Python object. We haven't sent any packets out yet. We're just showing a way to start describing what a packet might look like. And then, maybe we say destination equals FF456. This is about to be a broadcast packet or something with IP that has nothing specified. Scapy is just letting us detail out the bytes. In fact, I think we can type bytes of this thing, And these are like the bytes. These are the raw bytes going out over the network, right? Like this FFFFFFF thing is the destination MAC address. As we know, those are the first 6 bytes of an Ethernet frame. Then we've got 001122334455 that are the next bytes. Maybe at this point you're slowly. It doesn't matter if you don't recognize this, but maybe you're starting to remember that like IP over Ethernet is setting the type to 0x8000. You don't need to know this trivia fact, but maybe you start to recognize that sort of thing. And then we have a whole bunch of other things. These are just bytes. Nothing has happened to the network interface. We haven't talked to the network yet. We can start talking to the network with send P. And there's a whole bunch of documentation for this online. But what send P says, if I put a nice little question mark next to it, is that it sends packets at layer 2, which means Ethernet. I'm sending out Ethernet packets. There's also a send that's very confusing without the P at the end. It sends packets at layer 3. That means not with the Ethernet part. Like it's just starting at IP. We want to start at Ethernet, we go to send P. And SCAPI also has ARP. I can do, of course, if I want to send an ARP packet, it's going to be, if we look at the slides, it's ARP over Ethernet. There's going to be a destination that's going to be broadcasted. Right, we're going to end up broadcasting. We want to send this thing out. And as a reminder, I've got a whole bunch of windows open. Let's make it easy for ourselves. Let's watch this happen because I might mess this up. In fact, I know I'm going to mess this up. But we can confirm things with TCP dump. I'm going to run TCP dump -I any -n. And you know what? I'm also going to run it from over here. TCP dump -I docker 0 just to make it so it's less traffic. -n sudo. Okay. So I've got this, got this. I'm getting ready to send this thing. Send P. I sent a packet, right? All I did was set the destination to the broadcast destination address. I didn't even specify my source. I didn't specify anything in this ARP thing. This is probably a bad packet. And we can see what happens here. Okay, this, if you ever see IP6, just ignore it. This is IPv6 stuff going on in the background, and nothing in these challenges has to do with IPv6. IPv6 just loves to talk in the background, ignore it. IP6, ignore it. But we see that we sent out this packet as interpreted by TCP dump. It says who has 0.0.0 tell 172.17.03. So it looks like SCAPI actually filled in that 17.03 part for us automatically. In fact, I think if I change this to bytes, yeah, we would see in here, like SCAPI is trying to hold our hands through this and like fill in things by default for us. It actually did what I didn't realize it was going to do very nicely in this case, but you always double check. It did actually fill in our source Ethernet address in here, which is very nice of it. Alternatively, if I wanted to fill that in myself, I could do like IPA, look at this ETH0 thing, go in here, grab my MAC address. I think SCAPI has a function for doing this too, but you can always just do it the boring way. Just run IPA. You know how to get your MAC address. Go in here and set source equals that thing. And now we've explicitly set our source Ethernet address. And this is where like you really would refer to the slides where it says these bytes go here. Here are all the fields. We need to also fill in this ARP packet. I'm not going to do that here in this case, but hopefully it's very clear because we can literally see it with TCP dump, right? We are sending packets. Who has 000 tell 117.032? I'll actually, maybe we'll hint at it. There's this op field. And I think the SCAPI documentation is actually bad about this part. At least I haven't found it in the documentation. But we can test it with TCP dump. If I set op equal to 1, let's see what went out. It says who has. And if I set op equal to 2, it says reply, is at. So it's just 1 and 2. 1 is who has, 2 is at. The slides show this though. The numerical values of 1 and 2 correspond to those two operations. And so we didn't necessarily send the correct reply. We sent 172 1703, we wanted to say .2, but we could just fill in these last little bytes inside of this ARP thing and send the packet out. And then we didn't need to let the Linux kernel deal with this sending ARP packets out for us. We can just do it ourselves. And then suddenly this victim is talking to the wrong person. We can go way further with this. As you'll see in this module, we'll actually get in the middle of a conversation and start changing traffic partway through. It's going to be awesome. All right. Anyways, thank you all for attending and good luck. Any last comments, Jan?
On Wednesday, there's a really cool tool called Ettercap from way back when. I was using this tool in high school to play pranks on my friends. But we'll go through Ettercap maybe on Wednesday to see what other tooling there is in these parts.
Boomer Tools on Wednesday. See you and goodbye.